I'm not fine. How come no one knows? I wonder this one. They got new faces here. The likes of who is Charles Sungai. I've never seen this name. Who else? Okay.
Charles Mamone, is it?
This is a new face. Totally new name to me.
Sure.
Okay. Yes. Okay. Okay. My main concern is on your assignments. That's why I've decided to just have this meeting with you. Maybe to start off with, why are you having challenges, guys? Maybe it seems there's disaster in terms of the way you present your work. Are we having any challenges? What are your challenges, if any?
Hello, sir.
Yes. How are you?
I'm very good. I think if you may give us probably a sample of what you require. Probably we may think we are right, yet we are very lost.
Okay. So the issue is you know what to write, but in terms of how to use ARA or how to use data, everything you are covered, except that you want to know how my expectations. Is simple as that. No any other issues except that you want to know how to present your answers. Is that so?
Yes, maybe say. Also, like some of us, it's our first time to econometrics. Saka tinenge pamwe takatorasika. Maybe if you can guide us, tinogona kutibatsira tisati tananya kurashika like the other colleague said.
Okay. Who else? So those are the overall concerns. You want some direction in terms of how to respond to these issues. Is that the concern for everyone? Or there are some other guys with separate issues?
Hello, sir.
Yes, Marilyn.
May I kindly use the vernacular?
Okay.
Saying ndakamirira hangu vamwe vanga vasiri kutaura, and I totally do not understand. Like most of my concepts achonaga, I cannot get. I do not even know how to interpret my results. Ipapo ndo pane challenge yangu to start with. Then mixing ARA and Stata, they are also a challenge for me. Saka mino kana pane vakaenzana nini, but that's how I feel.
You want to mix ARA and Stata?
No, kuuza ARA and Stata zvinoto confusing.
Okay. Those are your concerns?
Yes. And also interpretation of my results.
Hello, sir.
Yes, who is this?
Yeah. My concern is, as I'm preparing for the exam, my major concern is that I'm unsure whether I'm supposed to claim all the codes for Stata, or I can bring the codes into the exam. It's not clear. Is this an open book, or we're supposed to know all the codes by head?
You don't need to claim the codes. You have to know the codes. But most probably as adults, you'll be having your own machines, so you're old enough to understand.
All right, sir.
Okay.
Nice.
Okay.
Hello, sir.
Who else? Yes.
Okay.
Machine.
Yeah. Thank you so much. I think that to start with, yeah, you know better how people performed from like the assignments. From our side, we might be thinking kuti zvatakanga taita zvaibvunzwa nequestion ndizvozvo like zvataifunga kuti zvaidiwa, but imimi pamakazomaka you totally saw kuti we were going in a different direction. So maybe this might be an issue of we are failing to interpret what the question is asking us to do. So like we are totally lost when we think kuti tiri kuita chaizvo. So maybe like I don't know kuti if it's possible kuti from the assignments we did, like kungotipa like a brief explanation kuti ano apa papaifanirwa kana kushanda the regression kana kuti apa papaifanirwa kushanda zvakati kana kuti apa papaifanirwa kushanda zvakati, because from my side ndaitofunga kuti zvandaiansa question ndichiita ndo zvanofanirwa kuitwa, yet I was lost.
Okay. So basically, everything comes down to the issue of knowing how to interpret your results. But in terms of coming up with the results, you're okay, right? Maybe if more than 50% of you knows how to maybe come up with the results. But when it comes to interpreting those results, I think that's where we are having a lot of challenges. So for those who don't know how to use data or R, for now, let's ignore that part. To start off with, maybe let's start with the interpreting the results. Interpreting the question, then of course, getting to know how best can we interpret those results from the output. So maybe without wasting much of your time, let me just touch on one question. But in terms of knowing which data set, which model or which, be it a regression model or whatever, to use on which type of data set, you are covered, right? To differentiate, this is time series data, this is cross-sectional data, this is panel data. You're okay with that, right?
If possible, say just take us through Chitungo. Okay.
I think maybe from the analysis you did from the assignment you marked, you might be in a better position. Were we able to interpret, is this a cross-sectional data? Is this a time series data? Because like we might think yet we are interpreting it wrongly.
The major challenge with you guys is you just copy and paste it from someone else. So it's most probably it's one person who did the results, who did the running in his data, then everyone else copy from that such person. So to say you don't know how to differentiate between those data types, then that would be something else. But from what I've learned from your assignments, your major issues are on interpreting the data set. I ended up ignoring those outputs from what you know.
Hello, sir.
Okay.
Hello.
Taura, can you Taura?
Yeah, Magadi, sir.
Okay.
I'm not including anyone, but on my own personal capacity. What I faced, my assignments are two paper. Number one, in the my assignments I'm going to and now I'm going to copy and paste. Then the second issue, whilst I was doing the assignments, you know, I normally have this kind of sense, you could indicate something. I don't question why my results are good so what, because I will be very much 100% sure of the. But on these, some of the test dzandaita, you see kuti zvafanana nekuti tikashandisa probability model, you suit your results ukatesta. Let's say ukatesta one, if you use one test to check or to do model diagnostics, inokupa a result inonga different from another test which is just testing the same concept. Ipapa ndo pandaishaya kuziva kuti saka chaizvo what is going on here, kuti I'm using the same data set but ndikuwana ma-conflicting results from different tests that are essentially doing the same thing. So which now brings me to the question yekuti ndave muexam manje, which test should I then probe kuti ndo anenge ari superior than the others? So that was the first issue. Then the next issue was actually define out une data set. Does this data set rinokwanisa here kuitwa neprobit or logit? Zvimwe zviri easy and straightforward, like a time series. You actually see this is a time series, but ipapa logit nemaprobit apa ndo pane imwe issue pa, because tikatotarisa kuti a logistic regression, some of the tests there dzatinotesta nadzo ku multiple regression hadzishandi ukangoita kudaro. I think in my first assignment ndakatoshandisa, instead of a multiple regression, instead of a logistic regression pakudazonozama kunoita ma-results paya ndakatozoona kuti ndakashandisa chi a multiple regression paya, because ndaiti ndikazama kuda kushandisa izvo zvairamba. Saka ndopa tisi kunyatsobata manje papa kuti what's going on. Ndapedza maita basi.
Who is Kutambura Garikai?
Kutambura Garikai is Ishmael. I'm the one who is speaking, sir.
Okay. And then who is Woko? And even Maunga Simbarashe. Do we have Maunga Simbarashe here? Or Magoche Dumisan? Those guys.
Yes.
Either Woko, Magoche, or who is this? Yes, those ones. Maunga, Magoche, then Woko. Any one of those guys.
Yes, it's Magoche Dumisan.
Okay. Can you give us your consent? I think you must have some consent. Basing on my assessment from this set.
Right. Our concerns, we were just saying that we just wanted to have input time so that we can get into the exams with our laptops and then we can write the exams.
Okay.
For me, sir, thank you for giving us an opportunity to also air our views. For us, some of us, we really don't have a firm background, both to computer science and also some other econometric business courses. So we'll be meeting some of these concepts for the first time. So our challenges started actually initially from trying to map the data sets to certain models, as well as interpretation of those results, like you said. So those were just some of our issues. Thank you, sir.
Okay, well, all right, thank you. It's on it. You get it. All right. Okay. Okay, so let me try to present on something. I hope my presentation is loading, isn't it? Okay. Okay. So I just want to touch on are you seeing my screen, guys?
Yes, sir.
Yes, we are.
Yes, sir.
Okay. I just want to emphasize on this question number 4. Okay. It was the use of technology adoption data. Of course, that Fumbuza one. Okay. So the first question was to say fit the model to the data by taking adoption as the independent variable and the rest is the dependent variables. So basically what I was expecting on this one was to simply have the model by simply choosing which model or which regression model best fits to this data. Remember, we said when the dependent variable is binary, that is to say it is categorical, either in this case it's adoption, it's either not adopted or adopted. So whenever you have such a dependent variable which is binary, then you must know which models to choose. And we said either you choose the probit model or the logistic model, or that other one, the first one, which we normally don't use. So we said this one is a dependent variable which is binary. So when you came across such a question, normally what you have to do is to first define or determine which model am I going to use. Looking at the data set, is it binary? Is it so? The first port of call is to determine the nature or the type, the data type. Meaning to say, is it category? Is it a time series? Is it cross-sectional? Is it whatever? So let me go and open this data set. Where is it? This one. You hoping you are still seeing my screen? Okay. Okay. All right. So we can tell from this variable, the adoption variable, we can tell that it's either 0, 1, 0, 1. Even if you look at from the question here, the description of these variables, you can tell that this is a binary setup. So we only have 3 options. It's either, but most probably we use 2 options, either the probit, the logit, or the tobit. But at this point, let's concentrate on these 2, the logit model or the probit model. So at this point, you've determined which model are you going to use, just by me looking at the nature of the dependent variable. So trying to fit the model, we're saying just run a code in either R or in Stata and come up with the result. So this stage of fitting, the 5 marks are distributed in this manner. First, identify the model which are going to use. Let's say you have chosen the logit model. You just fit the model. If you are in R, simply say, so the first port of call here is to import your data. Data importation, importing the data you've got its own marks. So that code, you have to present that code which you have something to do with inputting data. You've got some marks for that. Then writing the model. Say when you're in R, you can say, I'm not going to open R now, but in R, you then have to say your model, or you can store it, you say it's a model which is for a case of a logic, you can say GLM, then you write your equation there. Okay, that's the model. Okay, so let me open starter so that we see whatever we are doing. Okay, where is that starter file? Let me consider which one. Let me consider logistic regression. Okay, so I'm now opening starter because it's taking some time. Waiting for it now. Right. Okay, so I was saying importing the data itself, we've got some marks, isn't it? So in your solution, you have to show this one. So under question number, this question, so you simply write question 4.1. Then your solution then start off by pasting this code. Simply paste this code into Word. Where is the code? This one. Simply copy this word and paste it in Word. Right? Then the next one, there are two options which you can do. Of course, this one, maybe you may want to use this one. You can attach this code, this do file, or you can copy the code, paste it in Word. So the first part of code is to import the data set, which from those 5 marks, you've got you earn some marks by simply doing this, right? In the management of whatever, this one, of course, is okay, but no marks for this. Then the next part of code is now fitting the model. So by simply writing this line of code, you've got you earn some marks again. You have to show that this is the fitting model. Okay, so it's either use this one, we don't have any problems when you either use this or you use all the ratios. So you can either use the first one or the second one. No problem in that one. Okay, so having that, then you have to show us what the results. So let me run this one so that you can I show you everything. So let me run from here, maybe up to there. Right, I run. Okay, then after that, then I also have to run this. Let me run the first one, this one. Okay. Waiting for the results. Okay, so what are you going to do here? From those 5 marks, You just copy, or you can snip using this snipping tool, paste it in Word. Then you have fitted the model. So the first thing you have to do is to import the data set, and you have to show that in your answer script. Then again, fit the model using that logit command. Then you have to snip this one, the result, and show us in your answer script. You will be done for the first part. Do you have any challenges with it?
Sorry, sir, can I ask a question?
Okay.
What happens in the event that maybe I have an error within my code? It's the correct line of code, but then there's an error that I probably failed to fix. Do I get part marks for that if my code fails to run?
It depends with the distribution of marks. It's either maybe if that line of code you've got 2 marks, then of course you can get the part marks. But if full marks are awarded for someone who managed to debug everything, we expect no errors. But when your code you've got some similarities, or it's almost similar to what we expect, then you can have some part marks. But the issue is you have to be able to debug everything.
Okay. Sorry,
We don't expect any.
Sorry.
Okay.
Sorry, sir.
Yes.
When you were presenting, you presented 2 codes, isn't it?
Yes.
I don't see the difference, or may you take me through the 2 different codes and maybe try to shed more light where the difference is coming from, and I kind of drawn when you were presenting.
Which codes? Which codes is still? I've got.
Yeah, that one and the other one that you said, or.
This one I have highlighted is simply to give you some results which are almost similar to those of a multiple linear regression without the odd. Remember, do you know the formula for the general formula of a logistic regression model?
I've forgotten.
Okay, so let's go back to the wait. Okay, this one. The only difference is on, or let me do this. Let me run this line of code again so that you can see the difference. Maybe without doing anything. Okay. Can you see the difference now? Here, we've got coefficients. That's just like what we have when we run a multiple regression model. These are simply coefficients. Where you interpreting this one, you have to say something to do with probability changes or whatever. Remember, let's say, for example, maybe education years is significant in this issue, in this case. Which one is significant? Okay, let's take yearly income. So we're saying a unit change in yearly income would then force adoption to change by a probability of what? This much. This is, can you see the difference? Now, when we run this code with an OR, these are odds ratios at the end here. You want to replace the coefficient here with what? With the odds ratio. So interpreting these ones, you now say a unit change in yearly income will force the log odds of adoption to change by this magnitude. Can you see that?
Yes, I'm flowing.
Okay. So basically, this is the probability change associated with this. The only difference, can you see the difference here? From 1 going this side, from 0.001 to 8, then this side, it's again 0.001 to something. So the only difference is this is the changes in terms of, this is 1.00 change, probability change in adoption associated by a unit increase in yearly income. Can you see that?
Yeah, sure. It's now making sense to me.
Okay, so I want to see this one in your answer script so that I'm sure that you've done almost everything when it comes to fitting the model. So you earn maximum marks, all the marks, only if you have successfully imported your data set, you have fit your model, fitting the model in terms of writing that code, then showing your output. And that will constitute 5 marks.
Hello, sir.
Yeah.
Can we expect that question in the exam or a more similar question?
This is just an example of what you expect. Not to say this will be in your exam. No, I'm just interpreting some of these questions which are almost the structure will be almost like this.
I'm not
saying this. Okay. Okay. Okay, so the next part is now saying using appropriate tests. Test for multiple linearity and heteroscedasticity. Then the question goes on and say clearly state the null hypothesis, the null and alternative hypothesis, and the rejection criterion under each case. Okay. So under this, remember this question, we've got 10 marks. And the testing for multiple linearity, 5 marks, then heteroscedasticity, another 10 marks. So the first post of call is to state the null hypothesis, as well as the alternative one. So what are we saying? For heteroscedasticity, we're saying there is constant variance, right? There is constant variance as our null hypothesis. So it's simply right, H naught, there is constant variance. Or you can present that mathematically, it's up to you. Okay. So just stating the null hypothesis, you've got its own marks. Then also stating the next part of course, then to state the rejection criterion. You reject H naught when this such. That's another mark. Then from there, you now run your code. You show us the code which we have used for multiple linearity or for the head test or whatever. That one can be a VIF or something else. I think when we discussed this one, we covered almost everything under that aspect. So clearly state the null hypothesis under each one. Say, for example, heteroscedasticity, the null hypothesis says there's constant variance. So you just write H naught, there's constant variance. H1, there's no what if. Because there's no constant variance or something else. I think you know English better. Or mathematics. Then you state the rejection criterion. We only reject H naught if the p-value or something else is greater than what? Is less than 0.05. That is if you are to use the significant level of 0.05. You earn a mark for that. Then the other issue then is to do the actual testing, showing the code which you have used for either a multi-collinearity test, maybe it's a VIF, or a heteroscedasticity test, maybe it's a Bruch-Pagan test. It's up to you. Okay. Okay. So suppose you want to do a heteroscedasticity test. Let's run this code and see the results. Okay. Okay. Let me go back and check. I'm having some errors here. They must be able to debug this.
Hello, sir.
Yeah, no?
Yeah, that same error I was experiencing it. Whenever I was using probit or logistic error, regression,
Yeah.
I was getting that exact error. So that's why I used the FG test instead of the
Yes.
head test. I don't know now. That was the question that I've highlighted before to say, why do we have such errors? But if we do our conventional multiple regression, it works perfectly with no error. But if I then go with there, I don't know what's going on.
Okay. It's now depends. From my experience, I've seen that it now depends with the data set you are dealing with. So we can try an FG test. Isn't we did this before? Another. Okay, you now you have to put all the variables, right?
Yes, sir.
So we having challenge in exam, we having such sort of errors. Okay. Let me move this.
Try FG with a space in between tests, if I'm not mistaken.
Okay. No, it's just an FG test. Okay, let me try this. It's again giving same error.
What if you try to run the logic model again?
Do you have the package for the FG test? I think it's now an issue about the
Yeah,
package.
yeah. Yes. Do you have any other person with such a package so that we don't waste much time on this one?
Yeah, I think I do have that.
Okay, so you can present so that we don't waste time.
Okay, let me try to present.
Okay. Oh, yeah.
Mr. Blessing. Hello.
Yes, Kimton.
Is it possible to multiple codes same assignments?
Yes, it is. I will give you.
Because I think tikapinda tine codes then we can find our way kana zvikange zvakunyanya kutinetsa.
Okay, so now I'm running the FG test. I hope my screen is visible.
Sorry, Chow, can you, we are kindly asking Thomas to switch off the camera.
Okay. So make sure everyone you have to install the FG test so that you don't have challenges come exam time.
Tao, can you demonstrate how do we install this FG test?
Pane command yaiswa pachat apo ukaingoikopa ukaisa mucommand it should work.
Okay, thank you.
Kati phone.
Okay, so my battery is actually running very low, so I want to switch to mobile. Jeremiah, how do we interpret these results?
Okay, Chaura, are you done?
I think his laptop switched off. Was complaining about power.
Oh, power. Okay, so guys, can we all install this packet, the FG test, so that we not cry foul? Maybe this one comes out to be what we want to do. Okay, so
Sir?
yes.
I may have missed out on a question that was asked by Jeremiah, the response. Apologies if I'm taking you back. The issue of R or scatter, are we supposed to use both or we can use any one of them?
The question will specify, will determine which one to use. It's either use this or that, or it's up to you. The question will specify everything for you.
Okay, thank you.
Okay. So,
sorry, sir.
Yes.
It's Tendachirao. I just want to find out, we were trying to test for heteroscedasticity, and we were using the FG test. From what I'm reading, it's the FG test is used to test for multiple linearity. So I'm a bit confused now. Because when you were having the error, we're trying to test for heteroscedasticity.
For heteroscedasticity, yes.
Yes.
Actually, the FG test is for multiple linearity. Have you seen that?
Yes, I've noticed that. But when Taurai presented, it was like he's presenting for a solution for heteroscedasticity. So that's where I got lost now. Because that test is for multiple linearity, but we were trying to test for heteroscedasticity.
Test.
Yes.
Okay.
Good morning, sir.
Okay, Eve.
Yes, sir. Good morning, sir. Okay.
Yes, morning. How are you?
Yes, I have two questions. Maybe I could have missed one of them because my network has bad cheetah on and off. The first one is so for the exam, Tino submitted the script, which is the do file or the other script, and also a Word document, NEMA answers.
It's up to you. You can either do a snip. You can snip maybe that portion of a code, then paste it exactly on your answer script. So, for example, if you are doing question number 1, you simply script that one, paste it on your Word document, then you comment. Or you can attach the whole do file. It's up to you.
Okay, because there are some like sort of some mini theory questions. Can I write them and add my comments in the Moodle file?
No. It's better you present everything in Word document. Then a do file is only for a code. That will be better.
All right. Then my other question is like pani yataketa pa assignment yanga ine a dependent variable iri binary. What can we have a scenario whereby we have a dependent iri continuous, and then the independent, some of them could be binary. Tinoshandisa logistic regression here.
Logistic regression is only used when the dependent variable is continuous, is categorical. Otherwise, you use multiple linear.
Sorry, okay, and then not linear regression. All right. Okay, so no matter all right, the independent are binary, as long we consider the dependent variable.
Yes, just look at the dependent variable. When it is categorical, then use either probability, topity, or logic. Otherwise, use linear regression.
Right.
Yes.
Thank you.
Okay.
Hello, sir.
Yes.
If on this question, if I use the LPM, can I be penalized on that? Because it may not have, I may not have issues with the heteroscedasticity and the article linearity problems. I mean, testing them.
No problem. When the question is silent about which model to use, then you can choose any. You can choose any. No problem with that.
Hello guys. Ndadzoka mani. Mushina wangu adzi.
Hello.
Pane zvazombotaurwa ndanda kubvunza kuti pane nyaya FG test paper. If you look at the results now, hypothesis inenge yakanyora kuti multicollinearity against no multicollinearity against multicollinearity, but then pazasi pacho is it pazasi panotaura zveheteroscedasticity or something. Ukada uzvishandisa zvinhu izvozvo maresults anenge achiconflicta. Dei chimushini changu chisina kudzima, I would have showed you some of the things zvinozobuda pazasi ipapo. Zvezvitoconflicta pamaresults apa ndopana chibvunzwa kuti so which one is which. But inini zvangu paquestion iyoyi handiti takafita logistic regression sezvaitwa nasezvo zvacho. Ndakuda kuzama kuti IM test head test yaya ndikaona kuti hazvisi kuita, ndobva ndaidzosera kulinear yedu ingori simple yaya, ndobva ndazoita izvozvo because ndaona kuti results matest yaya haaiti ukamaita either ukangoita logistic regression or probit yaya or tobit hazvisi kubuda zvimaansa izvi.
So FG test is only for multicollinearity.
That one ndo zvanduti pamaresults unoona panenge pakanyorwa kunzi hanzi H not no multicollinearity, then alternative yacho inenge yakati multicollinearity. But if you scroll down hapana here pakanzi test for heteroscedasticity muzvimabox zviri pazasi. Or maybe I'm mixing things. Laptop yangu yadzima.
No, what you should consider is the underlying assumptions under FG test. What is considered? So it cannot be a multiple test for these two, say multicollinearity and the heteroscedasticity. So consider the element of multicollinearity only. If you are to reject, just reject. If you are to, not to reject, just consider either, the results what they're saying there. Then if you want to consider which variable maybe is highly collinear, so that you may say, I want to remove it or not, then you go and see the tables that are below there. The heteroscedasticity aspect there are not handy in explaining the model under consideration.
All right. Ndaibata. Saka then my next question would be, inini mu assignment ndakaisa ma results ese yayo and I explained my results ese yayo. Saka murairidzi vachazondita sei apo man? Because now ndatorwawo neconfusion kuti saka which is which.
Unfortunately, he's on mute. Otherwise, you should help us how we can mark that question.
Oh, okay. But pane zvataurwa nasema zvibata hanzi zvoni, unless kana kuti hanawo zvibata zvangu. Hanzi kana question isina kutaura, tinogona kungoshandisa linear model ingori straight yaya, then tozoshandisa matest aya ari kuramba acho. Ukatanga wangonorana a linear model isiri logistic ukazongozvipinza.
Hello guys. Linear model Kimchon. Linear model. Hello Kimchon. Tadi tambodzosera chimuti kuna lecture. Timbowapa nguva yawo because I think this time yange iri nguva yawo. Timbowambotipa direction. Apa I think we will be digressing takuita zvimwe zvinhu tozopedzisira takuconfuse. Timbowapa nguva yawo please.
Thank you so much, Lakson.
Thank you, Lakson, but say what mute so far. So we are waiting for him.
Guys, pane some guy akambo present, I think in the Gauss akambo present achitiitira the heteroscedasticity. Pane method yaakashandisa, I can't remember, maybe you can assist us there. Because I remember yakato sort of like being adopted trim lecture, something like that. Because that was a question that I got achibvunzwa, how do we test heteroscedasticity muma logistics models.
Tendai, hanzi timbomira lecture vambotaura ka.
Lecture wabuda wani, munaona vachiita exit.
Saka tangomira tinenge takutya
Maybe
kutaura
vaita
ka.
challenge pamwe is going to come back, but I just saw him leaving. Pandazotanga kutaura.
Alright, ndine gosi wacho akambotaura something, but we are just waiting for the lecturer to say something.
All right.
Wakomana hatingangomire ka. Vana Aaron naNata uchimbotaura zvamuna muchitaura svi. Zvine zvazviri kubatsira. Tozodzoka mudzidzisi wadzoka.
Sure, tete rungomhanya romahana.
Zvangu zvapera.
Aiwa, tauriwo uri kumodibheta Aaron.
Mana mudzidzisi tomira kudhibheta pachedu. You remember last past days we had our discussion and we had some pending issues that we needed to ask the lecturer. I think tikambomira kuargiwa pachedu isusu, maybe tongomubvunza ari iye otipindura even nangu tine answer. Let him answer iye varivo lecture. Then isu tozozvigadzisa takuita madiscussions edu and so forth. For the sake of time, izvi zvabuda maybe arikutoti hapana havane dzungu ndauya ndindovabatsira. I don't know.
I don't think that's the case. He's having network challenges. Eva, I don't know.
Plus the other thing, isusu amwe kana totonzwisisa kana totofunga zvatinofunga tichidondo ka, we have to lay it out there so that we get corrected along the way. Because what we need is to have a constructive argument here. Ivo vari kutibatsira at the same time toda kubatsirwa. Saka ukaramba wakanyarara kana usiruziva zvauri kuita uchindopinda muexam wakangonyarara. We have to be speaking out zvauri kufunga izvozvo so that we help each other to pass this exam.
I understand, Tao, but I think the problem will come pakuti the people vachiri kutry kutonzwisisa basics. So I feel like for someone asiri kutomboziva zvachose kana ma-concepts akawanda, because the thing is, for some people one idea, it's okay to be having these discussions because one idea of what's happening. But pane vanhu vasiri kutomboziva zvachose, so it becomes confusing to them because one person ari kutaura this thing, the other person ari kutaura that thing. So for munhu ari pazero, it makes it very confusing. For you guys, maybe it's okay because you're just sharpening and you're correcting zvishoma or zvoda kugadziriswa, but you know stuff already. But pane vanhu vatori pazero vari kutoda kubatsirikana, so it then becomes confusing for them.
Guys, handisi kuona pane confusion. Because zviri kutaurwa naTauka. It's not about knowing. Tau is mentioning a lot of things that are handy to what the questions are asking.
You like FG test and the multicollinearity, right? Then Tau is saying, but in what heteroscedasticity particularly here. Take it from someone asiri kutomboziva all of that. Because the thing is, for an argument or for a discussion to go on, kana utori nebase yauri kuziva, it helps, yes. Because only idea chikutaura chi. But for someone atori mudondo, it actually makes it worse. So you might not see the confusion because uri kuziva. But I think let's just try be understanding and also accommodating of other people asiri kutoziva.
Saka ngatimirire mudzidzisi vatipakurire.
Saka guys, imi muri kuti zvaitwa naana Tau izvi zviri wrong here kuramba wachibvunza. Inga tatobatsirika wani tairamba tingonyora H-test yedu ichiramba kurana. Ene zvamwe takutoziva kuti FG test inoshanda multicollinearity. Tati kumbozviziva. And hapana chamboitika chakashata. Wakomana wanzi na lecturer B mawo present. Dai lecturer wangu adangofamba nebhoro angorambidzwa nokupinda. Plus this discussion I think iri kutobatsira. But ameno tinenge todangogara tangopiwa code roti vatangonopinda tichidzimika code. Of which mumwe munhu anenge asingadi izvozvo arida kunzwisisawo haasungoda koti arida kunzwisisa isusu vamwe madofo tinongoda kupiwa koti saka ngatitrai kubatana pakata waitoka discussion kawo asi mukati vamana makuzonyanya kuenderera maybe isu tikati aiwa tinofanira kungopanawo pakati kwete tatoti ngatingomirire tingonzwa kuti mudzidzisi wari kuti waingotipa HTS zviyanzi yaramba yobva yanzi go and debug tobva tatadza futi toita sei
ndifanira kutudzako iyo yawanyora muchatbox iyi.
Guys, inini hangu ndine question yangu kuti pane individual assignment question 3A yai. Model yanga irichi painzi taura kuti which model is it? Amenoti lecturer vamboipindura here iwe.
Havasati rega vazotipindura.
Hapana ari kuziva.
Tikaita setinoziva tinozokonfisa vamwe saka rega mudzidzisi vazongotipindura.
Sha istato muclaiming mode chingotaura
vakomana musanyekuzvisa mwoyo muonesana pane varume apa.
Alright, can you come ku inbox kwangu undiudze zvako because as long as vanhu vachingodiscussa zvine maanswer it's okay.
Aaron ndepe
Tau.
Shama ndisiro ka message ku inbox kwangu pane zvandauratidza.
Tau naAaron muchinge matumirana kuma inbox muzosenda ku inbox kwangu ini.
Guys, ini ndine chichemo wanaita sana misheka wana hana una makutivharira panze manje. Aaron naTau nevamwe vese vanga vachingocontributa ini nangu neudofu hwangu ndanchibatsirika handina kana confusion yandanchimbowana ndanchitobatsirika kutoti alright mati FG test ndeye inotesta multicollinearity.
Kana mudzidzisi futi wabatsirika. Kana mudzidzisi futi wabatsirika.
Mudzidzisi watobatsirikawo because mudzidzisi watopa Tau chimuti vakati Tau displayer handiti.
Exactly.
Saka ina nombona pakanizika nawo
vanhu vari kuramba but hazvisi zvema-feelings izvi hapana munhu anzi asapresent. What we're just trying to say is yes kushare data kuri bo but izvezvi tiri paclaiming stage yayo yokuti some people are just taking zviri kutaurwa as ndo zvavari kunoisa kuexam. So the problem now becomes kana takuita back and forth pachedu vaya vakangomirirawo kureceiva kuti vazongoisa muexam zvakadaro vanoshaura kuti votora chipi. So not saying zvakashata zvashitika tachingoti ngatiiteiwo zvekuti hazvizoomeseriwo vamwe tichingoconsiderawo level yekuti tiri pamalevel akasiyana but hazvisi zvekuti hapana munhu ambonzi ngaasataure.
Ana ndikutoona kunge zvimwe zvavari kutotaura vakomana vaka ndo zvichatozobatsira vazhinji izvozvo because mudzidzisi ati inini I will not take an error. Saka I'm actually for these guys kuti varamba vachitaura.
And they can talk because the thing is people are now making it seem like zvanzi vanaTau ngavasataure or zvanzi vari kuziva ngavasataure. But I think I don't remember ndimesheki ranga achiti ngatimbomirei kuita like a back and forth pachedu. It's like tukuda data and but vakaitawo ari kuziva chakati otaura chakati, ari kuzivawo chakati otaura chakati, like something like that. Hapana umbonzi ngavasatauri.
True. I think people there's misconception here. What we were trying to say, the lecturer is, this is we had an idea, you go to lecture keep a roadmap, right? Then it according to what a better discussion, there are some things which we had pending issues where we need clarity and so forth. But the challenge now, we are confused arguments to which we could have done it discussion right? If we are to my point is, if we are to ask, let's ask it and lecturer straightforward kwa ari, then that's what was my point. Not to say we want that information from you guys. If I can share that information. It's not about guys we are doing show off or whatever. It's not that. I'm sorry if you take it that way, but it's not what we meant.
Yeah, yeah, all points taken. The thing, Jiten, I think all my concerns are valid. Yes, we need to tone it down, or whatever, to the lecturer, to tone progress and it. But we're now moving on to the next thing. Is this now tester for heteroscedasticity, which is why tazobvunza FG test it will test a chi. Because that assume maybe it's for heteroscedasticity, but then I went back to the notes and checked what is it testing. Then my authorities are good, it's for multicollinearity. On that was the issue why Tammy some zidisipazo end up a mute.
Guys, tikatarisa model yatanga tichirana, we're not running a linear regression model. Tanki rana was it a probit model? So a start yet test I shandi per probit or per logic model. You can Google that, and you for a probit or a logistic regression model, you use yet probit. That is what I Googled.
Hi, Angel. The question.
Sorry, Angel.
Sorry, Tom. When you use the head probit model, how are you treating the iterations? Because I remember that question we were to present something as a group. We had challenges. The head probe yakanga isiri kupera ma iterations. At the end of the day, isokupa any error. So how are we going to treat? Or maybe we were failing along the line. If you don't mind, maybe can you just try to share the code of how to do the head probe?
I think there's something that you put at the end. Okay, so your head probit, and if you list your dependent variable and independent variables, then you put a comma. You're supposed to put something at the end. I'm forgetting. Let me try to Google for the code. It's not showing my iterations. It just takes you to the result.
Thanks so much.
Notion. The issue of iteration, it has to do with the number of variables again. If the variables are too many, not sure about the threshold, iteration I pay and not error. But if you put around the 5-6 variables, then it will quickly finish the iteration.
Yes, thanks so much, Aaron. Then now the next question which we failed to answer on ourselves is how do we choose the variables that and how like the selection criteria of the variables that is at the end. That was the next question we failed to answer you.
That one is a very tricky question because variables are supported by theoretical underpinnings. So when it comes to models, like if you remember when I said the variables are classified into 3, either it's superfluous, detrimental, or useful. So when doing the try and error aspect, when you say if I put this variable, what happened to my main variable? Suppose you want to measure something against something. My main variable is the dependent variable, but I have to add other explanatory variable to explain the dependent variable. So I'm much focusing on the main variable. So if I add other dependent variable and changing the behavior of the main variable, for example, say inflation, to explain GDP, we always know in a priori that inflation is a negative impact on GDP unless cribbed. So if you add a certain variable, like to make it multiple and cause inflation to be positive, then we need to have a justification why it is positive, or rather we have to remove that variable. That's my thinking on that area.
It's okay, Aaron. Thanks so much. But like I like the part you said, it becomes tricky on how to choose or not to choose the variables. It's okay, thanks. Maybe let's just wait, Tony, and just saying pani something straight to the solution without the iterations. Let's wait and see on that. Thanks so much, Aaron. Thanks so much, Andrew.
Hi Eve, I heard you were talking to the lecturer. Pane zvichiri kuitika here kana kuti tosevha yedu data repo?
Hi. Hi, guys. Oh, okay. The lecturer said he's coming now. He was having connectivity issues, but he's now coming back.
As for claiming purposes, maybe varikuziva vanogona summarize in the meantime kuti I mean ini ndoda kuziva hangu yeah. Kuti heteroskedasticity inotestwa netest E, multicollinearity inotestwa nematest I, chakati chinotestwa nematest I. Tichimirira lecturer whatever patiri kuzocontinue. Ari kuziva.
I can comment on multicollinearity. You can use pairwise correlation test. Then you can also use the VIF test. Then EOEFG testing.
Okay.
Okay. I'll come on heteroskedasticity. Unotesta neonzi Bruch pagan test. Unongoti het test. Tata unongoti het test. Bruch pagan.
Sorry, Jeremiah, what did you say?
Sorry, Jeremiah, we cannot hear you.
Okay. For heteroskedasticity, unoshandisa inonzi Bruch pagan test. Kana pari pasata unongoti het test, then enter. Inobva yabudisa the Bruch pagan test. Then for autocorrelation, you are supposed to use but it's another name again, which is of origin.
But if I start inonzi head test.
Head test, yeah.
To add on, Jeremiah, on what you just said, that head test, it only works when you are using a linear model. With the other model, probit or what, it won't work. That's the error, which is why we're having an error. So when you are testing in a linear model, that's when head test work.
So for logic, you now know head probe. Head probe. Kuti ukwanise kuzo tester in for logit and probit models, because it has the same heteroskedasticity.
Then can I ask, Auntie?
Sorry, Jeremiah.
Tendai, right? I don't know. Angachiti era yatangachwana was because our model was not linear. So remember that thing you got T for models not linear. Oh, okay. Lecture away. Is it back?
Yes,
Lecturer Wapinda.
Yes, he is back.
Okay, it's fine.
Okay, guys. Tambotiza. Okay. Something. Okay, guys, welcome you back. I don't know what was happening with my network. Okay, so if from what I've realized, running a heteroskedasticity test on data which is not linear is a nightmare. That one is a nightmare. Okay, so for the sake of progress, whenever a question is binary on the independent variable, then let's ignore something to do with the heteroskedasticity test. Isn't it? Okay.
So just a question.
Okay.
Since logarizer, like the linear of the function or the model, quotiator linear, can we not use the head prob test kana in the scenario saying we can't use a head test because the model is non-linear?
Because yes, that might work, but I have not tested it. But you have an error in terms of the estimates, which will not have been generated.
Okay, so you're saying in that case we just skip testing for heteroscedasticity?
Yes, or we can test using, maybe you can use some graphs, some graphical representation where you have to check for the shape of the scatter plots of the residuals. Where you say standardize the residuals against the residuals themselves, then you check the shape. That one I think can win in that way. Not to say head test, or even if you are to use the head probe or head probe, everything you have the similar errors.
Okay, so thank you.
Okay, unless you have someone maybe with a solution to this, but from what I've done so far, this one is having a challenge. I think last time we have similar problems, right? I now want to believe that. We have similar challenges last time, right?
Yes, we did.
Okay, so I think from now going on, then we have to research more on that one. Maybe we can have anything, but from what I have done so far, to check for heteroscedasticity, that even that such a Bruch-Pagan test for a logistic regression or probability or something, a binary response model, it's a nightmare. Unless if someone can assist us on that aspect. But with to check for multiple linearity, it's okay. You can use that FG test. But now when it comes to this issue of checking if the residuals are constant, it's a nightmare. You can have a plot, of course, just plotting and check if they lie between zero. I think that one might work. But when it comes to having the Bruch-Pagan test or LM test, I think it's a nightmare.
The event that we plot and we check if they're linear, how do I then conclude? Do I comment, like, do I get the full marks if I just plot and then maybe comment based on the results of the plot?
Yeah, that one will be good. Okay. That one will be better. Yes.
Hello, sir?
Yes.
I was checking with the Woodridge 2002. He's suggesting for yet probit.
I have also. Okay, you can finish on.
Yes, but the challenge now with yet probit is if you are having many variables, the iteration is not ending, and when it ends, it's giving an error at the end of it.
On estimates, error on estimates, right?
Yes, I mean on the iterations part. When it is running the model, the iterations is not ending, like it's infinite sort of.
Okay.
Yeah.
So that's the challenge with data science. You come across new issues which you have to debug on your own. So debugging this one so far, let's use the plots. Do you have anyone with the contribution on that one in as far as this one is concerned? Okay, so maybe on the last part, okay, that one to state the appropriate hypothesis and test the joint significance of the independent variable. This one is very clear, right? In this case, you use the beta i's, right? To say the third part. So the first one, you have to state the hypothesis. To say all the beta i's are equals to 0. Then alternatively, you can say at least one beta I is different from that one. Then checking for this one, you have to check. You have to consider where is the model. This one, where is it? You have to use the LA chi-square combined with what the chi-square probability here. Or I'm yet to let me share the screen. Maybe that one. Okay. Are you now seeing my screen? I'm trying to upload it. Okay.
Yes, it's coming up.
Okay, so the third question, which says state the appropriate hypothesis and test the joint significance of the independent variables and interpret the results. So this one is very simple. State the hypothesis, where we say the coefficients, all the coefficients are equal to 0, meaning to say they are not doing any good in terms of determining the dependent variable adoption. So you can either use the mathematical way of saying H naught is equal to beta I, which is equal to beta 1 is equal to beta 2 is equal to beta 3, all the way up to beta n, of course, which are all equals to 0, meaning there's no independent variable which have got an effect on our dependent variable adoption. Then alternatively, then you can say at least one beta I or is equals to 0. Sorry, is not equals to 0. Meaning to say there are some independent variables which are, of course, significant in determining our dependent variable adoption. But that one will be okay. Then the next part will be to interpret the results. Interpreting the result is very simple. So you consider this one. Isn't this one the model? Or can use the first one, this part. So the joined significance of the model is explained by this portion here. So you have to interpret in terms of the chi-square, which is 36.81. Is this chi-square significant? You check the probability here. Then if it is significant, you can also comment on the pseudo R square, the contribution.
The pre-exam. Ya, saka ari kutaura zvese zvakatadzwa nevanhu.
Okay, Nyaradzo. Okay. Okay, thank you. All right. In terms of explaining the joint significance, touch up on these 4 things. Yeah, of course, the likelihood is something else. It's not part of this. But just concentrate on the log ratio chi-square, the probability chi-square, then the pseudo R square. This gives you the overall performance of all the variables on the dependent variable. So this one is it significant? And also you have to state the null hypothesis here, which we have already done that. Okay, so a probability which is 0 point something, it means that is very significant, right? So we reject the null hypothesis and conclude that at least one beta I is different from 0. Meaning to say at least one dependent variable have got an effect on our dependent variable. So at least one coefficient or at least one dependent variable has got an effect on the dependent variable. Then you comment on the joint significance using this pseudo R square. Meaning to say 23% variation in adoption is being explained by all these variables. I think you also have to comment on.
Sorry, sir. Can you please share your screen?
I'm sharing the screen.
The screen is being shared, boss.
Yes.
It might be your network.
So, Pastor, I think the screen is very much shared. Okay. So, Angel is saying you can use it probably no logo. I have tried that one with a no logo. I think we've covered such. So you can as well keep on trying any other thing and share with others. Maybe you can assist us on that aspect. Okay, if you are suggesting to use it probability, then no logo. I've tried that one. It won't work. Maybe it will work. I don't know. Okay. So in terms of answering this part 3, I think done. We will consider those 3 results here in terms of the chi-square, the probability associated with the chi-square, then the pseudo R-square. So you can make a conclusion based on whatever you've realized here. In terms of the pseudo R-square, it is how many variables? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 variables. They are contributing 23.4%. I think this is a bad model. So you can be writing all those. I think we don't have any challenges on this one. To say 23% variation in our dependent variable adaptation is being explained by those 9 variables. I think leaving that is 77% explained by any other variables which are not included in our model. That means something, isn't it? Okay, so the last part of this question now reads, test the significance of the slope coefficients. Then, of course, you are going to use a 5% significance level and interpret the coefficients of the model. I think this one is the simplest of all. It's very easy to come up with this. But the challenge with you guys on this aspect, you were very lazy. You were generalizing issues. To say all the variables are statistically they are not statistically significant. So remember, this is a 20-mark question. To say you have to interpret all this. Education is associated with a Z value of 1.65, right? And that is again associated with the p-value is given as 0.1, which is not statistically significant. So this therefore means that education is not statistically significant in determining our adoption, and thus we drop this variable. And you cannot go on and interpret a variable which is not statistically significant. So this one is out. That is part mark. Then we go on to experience. Again, we've associated the Z value of 1.65, which is again not significant, given a p-value of 0.099. Again, you drop this one, you go on until the end. So for those variables which are statistically significant, then you have to comment on their to say, for example, a unit change in Y income is associated with a 0. Whatever change in the probability or in the log odds of adoption. Meaning to say, if this one changes by that one, this one probably may change with this magnitude. Okay. Okay, sorry guys. So that is what we expect in terms of answering such a question. Despite the challenges on testing heteroscedasticity, what are the issues do you think might be included in this one, or subtractions or additions or contributions on this one?
Right, say. Hello? Say.
Yes, Chikuvanika Ken, yes.
Yes,
Go ahead.
say inini hangu ndakaita history saka ndiri kuita ndichiconfusika but ndandichiita ndichibatawo mbichana. Question yedu yanga ichibvunza kuti test the significance of the slope coefficients and it then interpret the coefficients of the model. Ndonzwisisa pakuti interpret the coefficients of the model ndo patinoshandisa that column yema-coefficients anditi but pakuinterpreta ma-slope coefficients nepamama kushandisa the probability ndandakuita confused manje. Amene mungakwanisa kundibatsirawo here mbichana. Sorry kukudzoserai kumashure.
Okay, the issue is, remember, this is a logistic regression model. You don't have to, that's why we normally want to use the log odds, not this one. That's why we normally want to use the log odds. So maybe for the sake of not confusing you guys, let's run a model with an OR at the end, so that we have a log odds. So that maybe if you are trying to interpret this one, we are not going to have any challenges in terms of the probabilities or something else. Are you answered maybe on that one?
I think in the things we say,
yeah, so that maybe when you are to interpret that one, maybe for low yearly income, you then say a unit change in yearly income will then force adoption to change by log odds of that one. Remember, the first port of call when you are to interpret this one is you have to go back to the table. I mean, this table says 0 for not adopted, 1 for adopted. Remember, let me take you back to our lecture notes. Maybe you can understand better. Okay. Okay, so if you look at this one, by nature, the logit model is defined by the probability, this pi, which is equals to this one. But let me, this one. It says the natural logarithm of pi. These are the log odds which we have been talking about. These are the log odds which are defined by this one. So when interpreting, you have to say something to do with the log odds. A change in maybe say x will be followed by a change in the log odds of what our adoption in our case by a magnitude of something else. So these are the log odds which are talking about. This is the log ratio, which is given by that one. Am I clear on that, or still need clarity? Sure. Do we have any other questions with regard to this question?
Yes, sir, I've got a question on the individual assignment, question 3A. What really confused me was takapiwa a sample output model, but then ukatarisa pama variables apana na loan, like initially tantine investment, then money supply, then per model panana a loan. What was the reason for that? That cannot it was just to confuse the students.
No, remember, this is a linear regression model which have got certain assumptions. One of the assumptions has something to do with the linearity, meaning to say there must be a linear relationship between the dependent and the independent variable. So when there is no such regression linearity, then you have to take some log. So this is they were trying to, in this model, I was trying to make sure that all the assumptions have not been violated. Remember what happens when there is multiple linearity in a model, or there is a heteroscedasticity. You have to transform those everything. Maybe you can take the natural logarithm, which is linear, or you can take the square roots, or you can square the variables. So in this case, we have decided to take the natural logarithm linear, so that we don't violate some of the assumption of classical linear regression model. So when you see those natural logarithm that is linear, it means that there were some assumptions which were evaluated. Then this was trying to maybe to address such issues. Most probably there was linearity, or there was multiple linearity, or the variance was not constant, or something like that, which we then addressed by taking natural logarithms. So in your interpretation, you also have to name this. Then means that, maybe, let's take an example, lean investment. This means that any change in natural logarithm of what investment is associated with what this lean GDP will then change by a magnitude of 0.41 something else. So interpreting this one, this was just a correction of some assumptions. Maybe they were violated in this model. So when you see something like lean, it means we took some natural logarithm in such a scenario, just like in this one.
Okay, so it remains a multilinear regression model, but with transformed variables.
Yes, or you can name it a logarithm multiple linear regression or something else, but it remains a multiple linear regression.
Okay, thank you.
Okay, any other issues? So there was a question which almost everyone was having challenges. Maybe, who is the question? Okay, this is the question again. The majority of you guys have challenges in this question to say, can we interpret the results, whatever, interpret this output, giving proper hypothesis and conclusions. So interpreting such an output, you have to start off with this part. Interpret the F test statistic, the F statistic, you also interpret in terms of the probability, the R square, the adjusted R square, the root mean square error. You interpret everything here. Then from there, you have to interpret all the coefficients in terms of the probabilities. Then from there, you also have to consider the dumping, what's on test, stating the null hypothesis under such a test, then interpret these results. This also you have to go on and interpret the H test, stating the brief pattern. Of course, in this case, it's already stated. Simply copying this one and put it paste on your answer script. The null hypothesis, the alternate hypothesis, you interpret the results to say we've got an chi-square of 1.04, which is not statistically significant. So in this case, we fail to reject the null hypothesis and conclude that there is constant variance. So in other words, when there is constant variance, what's your conclusion? The residuals are almost stochastic. As simple as that.
Hello, sir.
So don't take any everything on your input for granted. You have to interpret.
Hello, sir.
Yes.
Sorry to disturb. On the same question, on part A, if I say log model, am I wrong on that?
It's okay. It's okay, but generally it's a multiple linear regression model.
Okay.
There's no problem in that.
Then we are given SAP, that structure adjustment program. Suppose it is significance. How do I interpret it?
SAP?
Yes.
What? Okay. How do you interpret it in terms of?
No, I mean, if suppose it was statistically significant. In this case, it's insignificant. So it seems it's a dummy variable. Yes, it's a dummy variable. How do I interpret that one in relation to the dependent variable?
It's very simple. Mm-hmm. Simply say SAP. Where is SAP? Or is there?
Yes.
It's a dummy variable.
Yes.
So for a dummy variable, you start off with 0 and then go on to 1. So in this case, you can say a change in SAP, maybe a shift from 0 to 1. Are we together? Yes. It's as good as when you are going to interpret gender. A change from 0, maybe from 0 to 1, is associated with a change in the natural logarithm of GDP by a magnitude of 0.02, 0.028. You don't say a unit change. You don't simply say a unit change is something. You have to say a change in SAP, maybe from then you have to say for a period before year 19, maybe to a period after the year 2000 is then associated with a change in natural logarithm of GDP by a magnitude of say 0.028.
Clear. Thank you.
Similar, something like that. Just like what we do when it comes to gender. To say a change in gender, maybe from male to female, of course it's not practical, but you have to say something which then becomes practical. So all dummy variables have to take extra care when you are to interpret them. The interpretation is not as good. It's not just like the same like we did when we say interpret maybe interest or something else. Or a shift from whatever to this one, or a change from that one. I think you know English better. Or if you don't know English, then Anna can assist you. I think Anna is good in English.
Hello, sir.
Yes.
Kati a unit shift.
Yes, it's up to you. It's up to you. As long as it's literally correct. Hannah, are you there?
Yes, sir, I'm here.
Okay, explain just like what Nare used to do. When you assist us here.
It's correct. Like the last statement at Taro, the shift change.
So you can use your own English to explain everything there. You can say a shifty or a changey or I don't know. Okay. Are you answered? Who was that? Aaron?
Yes, sir, I'm answered. Thank you.
How were you going to interpret it yourself? Or how did you interpret it?
Yeah, that's the reason why I asked, because it was confusing me.
Okay. So any challenges? So for all the tests, I think we must make sure that you include the hypothesis to say H0, what is it saying? H1 again. Then from there you interpret the results, you give us a conclusion. I think we will be good to go. On every test, don't ignore all this output. You have to mention everything there in terms of the double and what's on test. Tell us that then from there you mention the hypothesis, you state the hypothesis, the pushback, and again you mention the hypothesis, then you conclude by saying now that we have got our p-values, our chi-square 1.49 is not statistically significant given a p-value, a chi-square p-value of 0.2229. As we can conclude at 5% significant level that our residuals have got a constant variance, which is what we really want, right? Then when your residuals are not do not have a constant variance, then you have to do some transformations to say take the natural logarithms, or you can square, you can do anything. Any other issues?
Hello, sir.
Okay, Jeremiah.
Thanks. Say on the main table, the first table which comes up fitted our model. If maybe we may beam that one where we have the F value exactly. Right. I've seen that you've been trying to summarize almost many things here, but maybe a quick one in summary. The first, the overall analysis where we are having the LR chi-square, the probability, and the pseudo R squared, that one, right? If you may guide me on the probability there, when it is less than, let's take level of significance is 0.05. When it is less than the 0.05, are we going to accept or reject? Then when we go down and on the main table where there are variables being explained in terms of odd ratios or coefficients, then we are looking at the p value. Then you guide me if we are following the same rule of thumb of saying when the probability is less than the level of significance, let's take 0.05, are we going to accept or reject? Is it following the same pattern or order with the top part? If you may guide that on that one, maybe it may make our exam easier. Thank you.
Okay, in terms of the probability, remember, a probability is associated with a test statistic. So in case of a logistic regression, the test statistic is the LR chi-square with 9 degrees of freedom. Then of course, that test statistic is 36.81. That one is associated with the probability of 0.000. So the rejection criterion is always like this. You have to reject H naught, which you must state. You have to reject H naught only if the probability, the associated probability is less than our significance level. So when that probability is less than our significant level, it means that that test statistic is significant, is statistically significant. Otherwise, it is not. So you reject your H naught only if the probability is less than the significance level. On every aspect, whether it's for that one, for joint contribution, or under in that table for P greater than modulus of Z, everything else, whenever your P value is less than your alpha level or your significance level, then you have to reject the null hypothesis. It doesn't matter wherever it is, whether in a regression model or it's in a panel data model or fixed effects models, anything else, as long as that P value is less than the significance level, then you must reject the hypothesis. And that decision to say the rejection criterion, you have to state it. I'm going to reject H naught only when that test statistic, you've got a P value which is less than the significance level, and they are good to go. Then when it comes to interpreting, only interpret those the odds ratios or the coefficients for variables which are statistically significant.
Okay, I think comment only those variables which are statistically significant. In other words, with the P values greater than the level of significance.
No. You only comment the coefficients for variables with a P value which is less than our significance level. But to start off with, you have to touch up on each and every variable to say this one have got this Z have got a Z value of 1.65, which is associated with the P value of 0.1. So this one is not statistically significant. Go on to the next. Then when it comes to interpreting the odds ratios or the coefficients, you only interpret those ones which are statistically significant. I think I'm clear on this one.
Hello, sir.
Okay. Yes, so.
Yes, I have a question on, I don't know if we have finished this one, but on forecasting, I have having a challenge on choosing, for example, if I say the model follows under AMA, and choosing the P and Q, that's where I know we have to use the STF and the PACF, yes. But how to choose the optimum, I mean the numbers we put there in, it was a nightmare there.
Choosing. Okay, it's okay. So with this one, no more comments on this one, right? So that we can move on to that one. I think that will be our last part. We don't have any other issues with regard to this question, right? Except that one which was raised by Enzo. So can we move on to time series? Okay, so let's just consider that one. Let's consider that one in R. Okay, in just a moment.
Okay, while we are waiting for the lecturer to come, pamanzwisisa here vakomana panyaya yekuti reject h naught when probability is less than 0.05 or of the level of significance. But on the concluding part now, when you reject h naught, you will be now concluding to say, is it statistically significant here or it's insignificant? When the p-value is less than 0.05, do you significant or not significant? Thank you. If someone may assist.
Can you come again, boss?
Okay, I was making some inquiry from the lecturer about the issue of p-value and the level of significance, where I say if the probability is 0 is less than the level of significance, let me just use 0.05. If p-value is less than 0.05, we heard that the rule of thumb is we reject the null hypothesis h naught. Now, following that order, assuming that it's less than 0.05, are we going to say it's significant or it's not significant? Can you assist? Because this pattern runs through from the top up to the bottom of the table.
Hi, Jeremiah.
Hi.
Yes.
Well, Panado explain. It's fine. You can explain.
Okay, I'll just take what I got. Maybe I'm wrong. He said when the probability, that's the p-value, is less than alpha, which is the level of significance level, we reject h naught, and it means that the variable is statistically significant, and the opposite is true. I don't know if this is correct, but this is what I got from him. Thank you.
Yeah, so if it is greater than that significance level, the conclusion is we fail to reject the null hypothesis.
To add on as well, Jeremiah, if you draw your normal distribution table, you will find kuti patinoti 5% kumatails kwekwe zvataita tichita statistics all ningi A level pataizodrawa tumaline twokudemarketa the 5% on the left side or on the right side of our normal distribution graph. Those areas that I highlight on the sides, normal rejection areas. So if your probability falls within those shaded areas, it becomes what? That forms your rejection for what? For the null hypothesis. So pataizo draw a vertical line cheating dopani 5% significance level, or we are at 95%. Everything which is on the shaded line, which is less than 5%, becomes what? Your rejection on either side. If you look at it in a two-way.
Thanks, hey. Thank you very much. Now it's making sense and more clearer.
Okay.
And also, sorry. Okay.
That was clarity on the p-values.
Yes, it was.
Okay. So, Aaron was asking, who was asking in terms of determining the P and Qs?
It's Aaron said.
Okay. So you can the easiest way of doing such maybe is to inspect, to have an inspection of the autocorrelation function and the partial autocorrelation functions. That ones can tell you more. Okay. But you can use the command, but when the data, the series, maybe when it is not stationary, and it becomes stationary after differencing once, then you can use the function auto-arima to determine the optimal leg for you. Have you seen that?
Yes.
There's an other code for that one. I'm failing to locate it. I think we did this last time. Our last example. What? Let me check. When you use the command auto.arima, it will you populate the optimal legs for you. But you can as well use the PACF and ACF to monitor that. So let me check so that we can have a practical example. My machine is a dual core, so hey, it takes time to open. So what was your challenge in terms of determining the optimal leg using an ACF?
The challenge was on the interpretation on the HCF aspect. Because when I was trying to Google finding out, you realize, because I was running using Starter, so you realize majority they will give you a set or a number of combination of the model. So that was what confused me, because it was like guesswork somehow.
Then you have to pick the one with the lowest information criterion. Have you tried that? To say when you are given a combination of models, which are say 5 or so, then you have to pick the one with the least either archaic information, whatever, or
on that part I understand, but if I run say the ACF, that graph comes I think that's where my issue now is. How do I depict the figures?
Okay. Remember, there is a significance line there. Remember, the most significant leg is determined by it. You have to cross that demarcation line. It's only that my laptop is taking time to do that. Okay. Let me check this. God.
So we are saying, given the boundaries, the +2 and the positive.
Those two boundaries.
Yes,
Yes.
but I have some spikes that are protruding those two boundaries. Suppose there are many, say 10.
Okay, let me give you something. So we have no problems in terms of determining that this series fits an ARMA model, or this series fits an AR model. You don't have challenges on that?
Yes, I don't have challenge on that. But the only challenge is determining the PIQ.
The optimal leg, PDQ.
The D part is fine because it's about differencing. But the P and Q now.
Okay.
Sorry, from this side, actually, we have challenges for determining how can I classify it to say ARMA model. Say what? A model.
Okay. Okay, you're saying you've got a challenge in determining which model to use on a series.
Confirmed, say.
Okay, so I gave you a summary on that one to say, for you to know that this series follows an AR process, an ARP process. You have to, looking at the ACF, it has to decay exponentially from leg P. You will see that maybe there will be first spikes, maybe leg 1, leg 2, then from leg 3, there will be an exponential decay. Everything else will lie below the boundary. And that one, we will definitely know that this is an ARP process. Then in terms of determining whether it is an MA process, it cuts off at leg Q. Meaning to say, looking at the ACF function, suddenly from the optimal leg, it just disappears. And the legs will be so very much insignificant in terms of the size. Hence the cutting off. Then for an ARMA PQ model, it decays from the maximum. Remember, looking at the ACF to determine whether this one follows an ARMA process or not, it has to decay from the maximum maybe of P or Q, whichever is maximum there. It decays exponentially from there. But the best way of doing that, maybe in ARA, is to say auto-ARIMA. Because in auto-ARIMA, when there is no need to difference, then you see it's either in ARMA or it's when your P is 0, it means that it now becomes an MA. Then when we have got P which is greater than 0 and MA greater than, then you have to, you then know that this is I'm dealing with an AMA process. So Aaron, are you still there, Aaron?
Yes, sir. I'm here.
Okay, so the best way to do that is to inspect the ACF and the PACF. Most probably the ACF. So that looking at those boundaries, you must be able to see whether this leg is significant or it's not. So the last leg to be significant, it becomes the optimal leg. Whether we'll have another spikes, maybe at leg 10 or something else, as long as we've got significant leg 1, leg 2, leg 3, then it cuts off or it decays. That one, no problem. As long as the first legs are cutting off, so you have to simply inspect the nature of those legs, whether they are cutting off or they are decaying. And that one, in using ARA, we have got no problem. You can say, use the command auto arima. In starter, you have to check for that one. Maybe if you have a list of those modules, you must be able to pick the one with the least information criteria. Most probably using the archaic information criteria.
Thank you so much, sir.
Okay. Unless, remember with the data science, even econometrics, you still have the room to look for maybe research on any other issues which might be simpler in any way, so that life becomes easy for you. You can research more on anything, then share with class so that we all benefit from whatever you have come out. So I think for now, unless there are some other issues, I want to rush to do something else. So it's a good day for now.
I have a last question, sir.
Okay.
Maybe for exam purposes, are we going to have questions interchangeably? Take for example, we did time series on R. Is it possible to, in the exam, to do quantitative time series using STAT, and maybe those legit models using ARA instead of STAT?
Expect anything. You have to know both. Maybe when it comes to time series, know how to do time series in STAT as well as in R. Then logit model the same, multiple linear regression the same, so that you will not cry foul. Are you answered?
Okay, thank you.
All right. Any other question?
Just a reminder, say, to email those do files.
Okay. It's okay.
Sorry, sir.
They do files for starters and also codes for ARA. Thank you. Just to emphasize.
Okay, for these ones. But they are these guys. Can these guys get in touch with me? There's who is Kajgemeri and Chabvam mustache Chabvam Peru Primrose. Who are these guys?
They are
part of us.
I say Chabam.
And And Mary is not there.
Hello, sir. I'm around.
Hey, so you guys, you have to get in touch with me later. Because you don't have Cosmark for now. For a reason of course best known to you. Okay, so can you get in touch with me? Then who is Mutskwauri Mufaro? I don't have your registration number. So as well you can get in touch with me later. Okay, so thank you guys. You have a good day.
Sorry, sir. Just
yes.
I wanted to ask are there likely to be some theoretical questions? I'm worried on typing.
No.
Okay.
It's a big no. No theory. But comments, interpretations, you expect.
Thank you.
And maybe as a tip off, do something to do with probability. Okay, thank you.
Thank you very much, sir. I was about to ask that question. You are the best lecturer.
No, what would about bootlicking there? Okay, so thank you.
Thank you.
All right. So those two guys, Mary and Primrose, yeah, get in touch with me. Thank you. Good day.
Thank you, sir.
Thank you, guys. Thank you, Mr. Mapinge. You have a wonderful